Section 1.9 is on inverse functions. The inverse function, which is denoted as f to the -1, but you say f inverse, can be found by interchanging the x and y. So I'm just going to switch the x and y. Okay, because you are switching the x and y, whatever's the domain of f becomes the range of f inverse. Whatever is the domain of f inverse should match the range of f because you are just interchanging the x and y's. Okay, for example 0, they give you f as a list of ordered pairs. If you want f inverse, all you have to do is interchange the x and y. So this and this. Okay, so the new function should be 7, 2, 5, -3, 0, 4. I just switched the x's and y's, so the domain and range kind of flipped on each other. Okay, and an inverse doesn't necessarily have to be a function, although in this case I could say that it is a function. Okay, more typically you find the inverse of a function represented by an equation. Okay, so I have f, for example, when I have f of x equals 2x plus 2, okay, I want to interchange the x and y in order to find f inverse for part A. If you recall that f of x equals 2x plus 2 is kind of like saying y equals 2x plus 2. Okay, so I'm going to change the y to an x and the x to a y, so I'm interchanging x and y. So instead of y equals 2x plus 2, I will have x equals 2y plus 2. If I want to express f inverse as f inverse x equals, I need to solve for y. Okay, so I'm going to minus the 2 to the other side. So I have x minus 2 equals 2y. I'm going to switch the equation around because for some reason that bothers people. Divide everything by 2. X over 2 minus 1. So f inverse of x is going to equal to x over 2 minus 1. Okay, I'm going to sketch a graph of this, and I'm going to sketch f and f inverse so we can see how they're related or remind you how they're related. Let's see. I'm going to go ahead and graph f first. So the y-intercept is 2. This is a line up 2 over 1. I'm just doing a sketch. Okay, so this is f. F inverse is also a line. The y-intercept's -1. What's the slope? The slope is 1 over 2. Okay, so it's going to go something like this. Okay, now if I'm just glancing at f and f inverse, because I exchanged the x and y, this actually reflects over the y equals x line. Okay, and you don't have to draw the y equals x line, but I want to draw it so you can see how it's related. Y equals x has a y-intercept of 0, a slope of 1 over 1. I'm going to make it a dashed line because it's not really part of the graph. Okay, if I look at f and f inverse, they do appear to be reflecting over the y equals x line, and they actually equal each other where they hit the y equals x line because the two functions should match if y and x are exactly the same. Okay, now I'm going to look at the domain and range of f and f inverse. Okay, so for f, I can see the domain is all reals or negative infinity to infinity. Same with the range, it goes down and up forever. Okay, and then for f inverse, it appears to be the same. Okay, even if I didn't know what the domain for and range for f inverse were, I do know that the domain of f must match the range of f inverse, which they do. And the range of f and the domain of f inverse should match because I'm interchanging the x and y. And this becomes more important on functions where there is a limit in the domain or the range. Okay, for example 2, I'm going to do the same steps except for now I'm going to consider the function g of x equals the square root of x plus 3, partly just because I can tell there's a domain restriction and I want to see how that plays out in the graph and the function. So to find g inverse, instead of y equals square root x plus 3, I'm going to say x equals the square root of y plus 3. Okay, and then I'm going to solve for y. So I'm going to go ahead and square both sides. Okay, and then I can subtract 3. Okay, so g inverse is equal to x squared minus 3. Okay, I'm going to very carefully sketch a graph. Okay, let's see. Okay, so g of x is root x plus 3, so it's shifting to the left 3, 1, 2, 3, and it's a radical function. So it should go something like this. That seems reasonable. Okay, now g inverse x equals x squared minus 3, and that appears to be a parabola. Okay, which is a little weird because looking at my graph, the square root function looks like half a parabola. So I'm going to kind of plot out the points and then I'm going to think about this ahead of time. Okay, if I were plotting a parabola, it goes down 3. It would have points on either side, something like that, depending on how exact you are. And it would kind of make that nice U shape. Okay, I'm going to examine the domain and range before I continue because I already know something's wrong because there's not a parabola going sideways. Okay, so the domain of g of x, see it's a radical. So x plus 3 has to be greater or equal to 0. So x is greater or equal to negative 3, which means this goes from negative 3 to infinity. Or I could just look at the graph and I can see that x starts at negative 3 and it goes to the right. Okay, the range, okay, I know the square root's not going to be lower than 0, so it's going to be from 0 to infinity. Or if I look at the graph, 0 and going up. Okay, even though I haven't graphed my parabola yet because I sense trouble, I know that this should match this. Okay, which it does look like it does because the parabola goes down to negative 3 and then it goes up. So that looks okay. I also know that the domain should match the range. Okay, now that is not something my parabola does. My parabola looks like it's going to be graphed from negative infinity to infinity. So I need to go back and honor the domain. Okay, so the domain of f inverse must be only from 0 to infinity, including 0. So this is really saying x is greater or equal to 0. So even though I have two halves of the parabola, I only want to graph the half where x is greater or equal to 0. So that's this, and it's going this way. Okay, that looks right because even though it doesn't ask me to, if I drew the y equals x line, it would look like it's reflecting across that line. If I had drawn the full parabola, it would not have looked correct and I would have known to go back and double check. Okay, sometimes you just want to verify that two functions are in fact inverses. And the way you do so is you do f of f inverse of x and see if that equals x. And f inverse of f of x should also equal x because the y's, everything should cancel out because you're kind of undoing everything you did. So I have the function f of x equals the fifth root of x minus 4 and g of x equals x to the fifth plus 4. I want to confirm that these are inverses of each other or prove that they're not inverses of each other. Okay, so I need to compose them two ways. So it doesn't matter which one you do first, they need to both work. So if I do f of g of x, okay, I'm doing the fifth root of what's g of x? G of x is x to the fifth plus 4, and then minus 4. Okay, the 4's cancel, so I have the fifth root of x to the fifth. Fifth root of x to the fifth is just x. So when I go in that direction, it does seem to confirm that they're inverses. Now I'm going to do g of f of x to make sure it works in the other direction. So g of x is x to the fifth plus 4. So I'm going to do the fifth root of x plus 4 to the fifth plus 4. And I already made a mistake. Let me erase that. There should be a minus sign, huh? Okay, and now I'm going to simplify this, and it should, if they are in fact inverses, this should work. Okay, the fifth power and the fifth root cancel. So I'm going to get x minus 4, and then I have this plus 4 at the end. Okay, and that's going to equal to x. So it does work in both directions, which means f and g are inverses of each other. Okay, for the last example, we're just going to practice finding the inverses algebraically. There's no trick, it's just to see what it might look like in different situations. Okay, so f of x equals x cubed minus 10 is y equals x cubed minus 10, so I'm going to interchange the x and the y. And then I'm going to isolate the y so I can see what the inverse is equal to. So I'm going to add the 10 over. Okay, and then to cancel the third power, I'm going to do the third root. Okay, so then I get y equals the third root of x plus 10, but I'm really trying to express that this is the inverse of f. So f inverse of x equals the third root of x plus 10. You don't need, there is no domain restriction, but you wouldn't need to state it unless it specifically asks you to. Okay, I'm going to do the same thing for b. b is g of x equals negative 5 over x. This does have a domain restriction, but we will assume everyone's respecting domain. So it's y equals negative 5 over x. I'm going to change it to x equals negative 5 over y. Let's see, I'm going to times the y to the opposite side to cancel the y out. xy equals negative 5. I'm isolating the y, so y equals negative 5 over x, which means the inverse of g is equal to negative 5 over x, which kind of makes sense because if you imagine this rational function and then you reflect it over the y equals x line, it would actually look exactly the same. Okay, and then there's one more, and this one has a little bit of algebra to it. Okay, let's see. Okay, I have y equals x plus 5 over x minus 2. So I'm going to make it x equals y plus 5 over y minus 2. And there's multiple ways to do it, and we should have similar answers. I'm going to multiply by the y minus 2. Okay, so x times y minus 2 equals y plus 5. I think I'm going to go ahead and distribute so I can get the y's a little more separated. Okay, I'm not sure what to do, but I'm at least going to get the y's to the same side of the equation so I can try to isolate them after that. So I'm going to keep the xy on this side, and I'm going to minus the other y to this side. Okay, I'm going to move the 2x to the other side and the plus 5 here. Okay, now the y's are at least on the same side of the equation, but I want to isolate them. So I'm actually going to factor the y out so I can get it by itself. If I do this, then y times x gives me xy minus y times 1 gives me y. Okay, at least the y is isolated now, so I can divide the x minus 1 to the opposite side. Okay, and then I'm going to rewrite this in inverse. So this is h inverse of x equals 2x plus 5 over x minus 1. And if you had done kind of the opposite steps as me, you would have opposite signs that would be equivalent to this expression.